Hello, my name is Taylor Clementz, and welcome to my capstone presentation titled Threatened Green Sturgeon: How Video Analysis Can Be Used to Quantify and Reduce Bycatch. The southern distinct population segment green sturgeon is a protected species listed as threatened under the Federal Endangered Species Act and are found off the coast of Washington, Oregon, and California, but primarily spawn in the Sacramento River, which has been identified as critical habitat by the National Marine Fisheries Service, along with numerous other bays off the coast of California, Oregon, and Washington. The California halibut bottom trawl fishery also operates off the coast of California. NOAA Fisheries and the California Department of Fish and Wildlife have partnered with fishermen operating in the California halibut bottom trawl fishery who primarily fish out of Half Moon Bay in the Port of San Francisco, which is where the Sacramento River flows into. Because the fishery operates in green sturgeon territory, there is interaction between the species and bottom trawling gear. When fishermen target California halibut and catch non-target species such as green sturgeon, this is called bycatch, and it can be fatal for the non-target species. Therefore, identifying how green sturgeon interact with bottom trawling fishing gear can improve fisheries management techniques and guide gear modification development. We can do this by observing the green sturgeon's behavioral responses while coming into contact with the bottom trawling gear. Based on this information, I decided to focus on a few factors to consider to effectively manage the green sturgeon. First, when do green sturgeon interact with bottom trawling gear? Then, where do they interact with the gear? And finally, what are the outcomes of this interaction in terms of mortality and escape? In order to answer these questions, I interned with NOAA Fisheries in partnership with the California Department of Fish and Wildlife, examining green sturgeon interactions with bottom trawling gear. NOAA and CDFW have worked with fishermen to install cameras on bottom trawling gear capturing footage of green sturgeon and numerous other species. I analyzed 18 green sturgeon video clips, identifying variables including behavioral descriptions, size estimations, and the likely outcomes of fish gear interactions. I reviewed 26 hours of unwatched footage, identifying one new green sturgeon clip. I conducted a literature review focused on potential gear modifications that could reduce green sturgeon bycatch, and I worked on a fisheries management and evaluation plan for the state of California. So, what did I find? In my literature review, I found that the highest average green sturgeon bycatch in the California halibut bottom trawl fishery occurs in the late spring and late fall to early winter, with the lowest rates being observed in the late winter. I was curious to see how this overlapped with the clips that I had. NOAA and CDFW have footage from the months of March to October during normal trawl operations on these fishing vessels. Even due to the small sample size and footage from 8 out of 12 months of the year, I did notice that there is a similar trend as the literature indicated, with a majority of bycatch being concentrated from late spring to early winter, with the most observations in October, which is shown in Figure 2 on the top right-hand side of your screen. In my literature review, I also looked at the depth at which the California halibut bottom trawl fishery operates and the depth at which green sturgeon typically live in and are caught. The California halibut bottom trawl fishery has a mean depth tow of 19 plus or minus 9 fathoms. Most green sturgeon bycatch is observed in trawl depths less than 40 fathoms. The hauls that have observed green sturgeon bycatch have fished at an average depth of 7.4 fathoms and 9.13 fathoms, which is on the low end or slightly lower than what the literature indicates. It is important to note that currently we only have data through 2021, so this depth information does not include every trawl in which a green sturgeon was observed on deck or on camera. Next, mortality. Looking at mortality is important in understanding the full scope of impact that bycatch in this fishery has on the green sturgeon population. The West Coast Groundfish Observer Program is responsible for observing hauls and noting instances of bycatch. They also collect fin ray samples when encountering dead sturgeon. Very few fin ray samples have been collected, indicating low mortality rates while the sturgeon is on deck. The literature indicates that 18% of green sturgeon die after being caught and released, and 82% of the sturgeon survive. With this information, I wanted to look at the outcomes of what happens when a sturgeon interacts with the net, whether or not caught. So this takes us to the probability of escape. First, I looked at, was the sturgeon able to escape the net, which was determined by whether or not an observer had recorded a green sturgeon on deck of the fishing vessel in that tow. Then I determined if the same individual seen on the screen was observed on deck. If there was a green sturgeon recorded on the deck for that tow, then this was determined by whether or not the fish was estimated to be of a similar size as the one observed on deck. Lastly, I looked at whether the fish was seen repeatedly in multiple different clips. This was determined by looking at clips from the same tow on the same day, whether the clips were close together in timestamp, and whether the green sturgeon observed in the clips was estimated to be a similar size. Figure 3, titled Green Sturgeon Observations, shows the probability of the frequency of high, medium, or low likelihoods for each variable that I just discussed in each clip. And this is seen on the bottom right-hand side of your screen. One thing that really stood out about this figure is that if there were multiple clips from the same day, there was an overall very high chance that the same sturgeon was seen in multiple clips. So, why is this important? The video analysis template that I spent a large portion of my internship creating will serve as a template for future interns to gather more information on green sturgeon behavior and how they react to the net, eventually helping in conversations with the fishermen about their nets and when creating gear modifications. It is important to note that the existing base of knowledge on green sturgeon bycatch and bycatch reduction is small, and future research is needed and should focus on the seasonal implications in bycatch and the depth at which bycatch takes place. So with that, I would like to give a huge thank you to my site supervisor, Susan Wang, my faculty advisor, Andre Punt, for all of their help and feedback, and to all of my friends and family for their unwavering support throughout this journey. Thank you.